Salam everyone. Today I am going to discuss a very important method of integration which is known as integration by parts. So let's talk about its applicability first. It is used when other methods of integrations like integration by partial fraction or integration by substitutions may not be used. As you know well, integration by partial fraction is used when a function is given in terms of algebraic expressions in the form of px upon qx, and integration by substitution is used when we have to integrate a function in the form of product of two functions in such a way that one function is the differential coefficient of the other, or at least a function must be differential coefficient of a part of the function. But as you see, if we take the example integral x square sin x dx, here the function is the product of two functions. One is algebraic and other is trigonometric. So here, as you see, this is not pure algebraic form, neither it is given in the form of px upon qx. So condition of applicability of partial fractions is not satisfied in this. Further, the applicability of the method of substitution is also not satisfied because either of the two functions is not a differential coefficient of the other. X square is not differential coefficient of sine or a part of sine x. Neither sine x is a differential coefficient of x square or a part of x square. So none of the two methods may be used here. So in this particular situation we use integration by parts. So what's integration by parts? Let's talk about. Basically, integration by parts is a formula which is integral of first into second. Here first and second means first function and second function dx is equal to first function as it is, integral of the second function minus integral as a whole, differential of first and integral of the second dx. Here we have made these two integral sign is smaller and this one is bigger in size, because here this is small integral sign means only we have to use the integral variable part of the function, neither constant of integration or dx in both places. But here we have to integrate this product again with respect to x. So we have taken this integral in bigger size in comparison to these two. So let's perform it. For example, this is the function x square sin x dx. So this is first function and this is second function. So according to a formula, first function is x square should be as it is, and integral of the second sine, integral of sine is minus cos x, so minus cos x minus integral as a whole, differential of first, the differential of x square is 2x, and integral of the second is the same as we have written outside, minus cos x dx. So simplifying we get minus x square cos x, this minus will multiply, this minus becomes plus integral 2x cos x dx. And we have to repeat this process until we have no integration sign. So again we have an integration sign and again we have the product of two functions. So we need to apply integration by parts again, assuming this as first function and this is as the second function, is equal to x square cos x. So first function as it is, integral of the second, that is integral of cos x, which is sin x, minus integral as a whole, differential of first, so differential of 2x is 2, and integral of the second, which is sin x dx. So minus x square cos x plus 2x sin x minus 2, and here only one function is there, sin x, which is integrated easily into minus cos x, because the integral of sin x is minus cos x, so we simply write minus cos x, and we need not to use the integration by parts again here, because there is single variable function. So integral of sin x is simply written minus cos x and plus c, the constant of integration. So finally we get minus x square cos x plus 2x sin x minus into minus plus 2 cos x plus c. So this is the way to perform integration by parts. Now let me tell you one very important point here, that the sequence of the function in this method is extremely important. That means the assuming first and the second function is very important, that to which function we are assuming first function and to which function we are assuming as second function. This is extremely important. As you see, we have integrated x square sin x dx easily within 3 or 4 steps. Now let's see what happens if we change the sequence of the functions sin x into x square. So first function is sin x and second function is x square, because multiplication is commutative, so we may write x square sin x as sin x into x square, but here the sequence matters very much. So you see, by integration by parts, first function as it is, integral of the second, which is x cube upon 3, minus integral as a whole, differential of first, that is cos x, and integration of the second as x cube upon 3 dx. Now we have again sign of integration, so we may write it as x cube upon 3 sin x. Now again we need to apply integration by parts. So first function as it is, and the integral of the second one, x is to the power 4 upon 12, minus integral as a whole, differential of first, that is minus sin x, and integral of the second integral is as x raised to power 4 upon 12 dx, and that's it. Now if we opening up, we get x cube upon 3 sin x minus x raised to the power 4 upon 12 cos x, and this minus into minus becomes plus, and when we open this bracket again it becomes minus, so minus 1 upon 12 integral x raised to the power 4 sin x into x raised to the power 4 dx. So as we observe, then in every step the power of x is going to be increased. Initially it was x square, and then it becomes cube, then it becomes x to the power 4, and so on. As you see, when we have taken x square as the first function and sin x as the second function, we have completed the integral in 3 or 4 steps. But after changing the sequence of these two functions, this is never ending process. So it is very important to understand that to which function we have to take as first function and to which function we have to take as second function. So now the question is there any rule regarding this? Yes, the rule is eyelid, or we may say that it's a trick to remember the pattern or the sequence of the functions, or we can say the recommended order of the functions in which we have to take them as first and second. So what is ILATE? ILATE is a word, you can easily memorize it, and we have to take the functions as the first and the second function in this sequence from left to right. And here what is I? I stands for inverse trigonometric function. L stands for logarithmic function. A stands for algebraic function. T stands for trigonometric function. And E stands for exponential function. So if we take the function as first and the second function in this sequence, we will never have any problem. So if you see, we have taken x square as the first and sine x as the second function initially, so our integral was very simple. And what we have done, we have taken algebraic function first and trigonometric function as the second one. So you see, in this, algebraic function comes first and trigonometric comes afterwards. So algebraic function should be taken the first function and trigonometric function should be taken as the second function if these two kinds of functions we have in the product of the integral. Let's check the sequence of the functions. So ILATE, here I stands for inverse trigonometric functions. So as you see, tan inverse x is an inverse trigonometric function. So by our sequence, inverse trigonometric function should always be the first function. So an algebraic function should come after inverse trigonometric function. So this sequence is not correct or not suitable for integration by parts. So let's change it. Integral tan inverse x into x dx. So we made x as the second and tan inverse x as the first function. So now we may use integration by parts because these functions are written according to ILATE. So first function as it is, and integral of the second x square upon 2 minus integral as a whole, differential of first, differential of tan inverse x, as you know well, is 1 upon 1 plus x square, and integral of the second, as we have written outside, x square upon 2 dx. So we have x square, now we may write x square upon 2 before tan inverse x because we don't have to integrate this part now. So x square upon 2 tan inverse x. Now this half should be taken out because it is constant coefficient, and we have in the numerator x square and in denominator 1 plus x square dx. So x square upon 2 tan inverse x minus half, and as you see, x square may be written as 1 plus x square minus 1 because simply we have added and subtracted 1. So in denominator we have only 1 plus x square dx. Now we may split them up, x square upon 2 tan inverse x minus half, and when we split them up, 1 plus x square would be divided by 1 plus x square exactly, and we have only 1 dx. and here minus into minus plus half integral. When 1 is divided by 1 plus x square, we have simply 1 upon 1 plus x square, which is integrable easily. So one more step, x square upon 2 tan inverse x minus half integral of 1 is x, and in plus half integral of 1 upon 1 plus x square is tan inverse x plus c, and that's it. Now one more important point is that sometimes we have such a function in the form of product of two functions where we use integration by parts, that on the right hand side, while using integration by parts, the integrand is replicated on the right hand side. That means the function to be integrated, when integrated by parts, it is replicated again on the right hand side. So what happens then? So we have taken such a case. Suppose we have to integrate sin x into e raised to the power x dx. So we have to take this as first and this as the second function. So first function as it is, and integral of the second is same, because integral of e raised to power x is e raised to power x, and minus integral as a whole, differential of sine is cos x, and integral of e raised to the power x is e raised to the power x dx. So sine x into e raised to the power x, again we need to use integration by parts, taking this as first and this as second, because exponential function according to Euler's sequence should be assumed as the second one always. So minus, and putting a square bracket, applying the integration by parts in this now, first function as it is, integral of the second minus integral as a whole, differential of first, that is minus sin x, and integral of the second e raised to the power x dx, bracket close. Now if we open the bracket up, we get sin x e raised to the power x minus cos x e raised to the power x. This minus and minus becomes plus, and when we open up this bracket, this minus makes this plus sign again minus, so we write minus integral sin x e raised to the power x dx. As you see, our original integral is integral sin x e raised to the power x dx, and here in this step we get the same integral sin x e raised to the power x dx. That is, the integral is replicated on the left hand side. So in this case what we have to do, we have to transpose this integral as it is on the left hand side. So transposing this term to left hand side, because this is minus, it becomes plus over here, so it will be added to left hand side, and being this identical terms, both should be added, and we get 2 integral sin x into e raised to the power x dx. On the right hand side we have sin x into e raised to the power x minus cos x into e raised to the power x. So now we have to take e raised to the power x common out of them, e raised to the power x sin x minus cos x in the bracket, and finally we have to transpose 2 to right hand side, so we get integral sin x into e raised to the power x dx is equal to e raised to the power x upon 2 sin x minus cos x plus c, because constant of integration is must in indefinite integrals. As I have told in the beginning of the video that integration by parts method is used when we need to integrate a function which is given as a product of two functions, and none of the other methods of integrations could be used, but here is one more case where we need to integrate only a single function, but it is impossible to integrate that function unless we take unity, that is 1, as the second function in the product of that function. As for example, if we need to integrate tan inverse x dx only, so this is quite difficult, or sometimes it becomes impossible to integrate unless we take 1 as the second function. So tan inverse x is taken as the first function and the 1 is taken as the second function, that is constant function. And then we use integration by parts method. So the first function as it is, integral of the second one is x minus integral as a whole differential of first, differential of tan inverse x, as you know well, 1 upon 1 plus x square, and integral of the second one, that is x again dx. So we may write it as x tan inverse x minus, so writing half outside the sign of this symbol of integration, we may write it as 2x in the numerator and 1 plus x square in the denominator. So what we have done, we have simply multiplied and divided the numerator and denominator, or we have multiplied numerator and denominator by 2. What we have done this because if we assume this function as u, 2x dx becomes du. So this part is a function which may be integrated by substitution easily. So x tan inverse x minus half, if we take it as u, it becomes du, and simply we have 1 upon u du. So integral is log u, and then finally we have to substitute the value of u, which is 1 plus x square. So directly we may integrate it as log 1 plus x square plus c. So this is one more application of the method integration by parts.